This presentation is on the uses of process economic software in chemical engineering, and it was prepared by Group 29. The question is, what are process economic software programs, and why are they needed in the chemical engineering discipline? Well, we can all agree that chemical engineering projects are incredibly complex. The reason for this is because there are so many variables to consider, not just from a technical point of view, but a financial one as well. When economic evaluations are not competently done, the result of this is that many startup businesses fail, or it may lead to unsustainable operational costs for already established plants. This is where process economic software programs come into play, as they help bridge the gap between engineering and finance. They do so by performing these three core functionalities highlighted below. The first of which is they make techno-economic analysis of plants possible. They do so by using key financial indicators like the net profit value and return of investment, as well as many other techno-economic matrices. Also, they enable sustainable process development and ensure that plants which are designed and optimized using process economic software and ensure that profit margins are sustained or they can be scaled to a larger margin or projection. Finally, they enable enhanced decision making on both technical and economic fronts, that is, on both the parts of the engineers as well as investors. And this ensures that engineers make the best possible technical decisions that yield the highest economic results. This keeps everyone happy in the company. These reasons make process economic software tools indispensable for modern chemical engineers, because they have transformed how industrial systems are designed, evaluated, and optimized. Aspen Process Economic Analyzer, Honeywell Experian, and Aspen HYSYS are some of these software programs. Before we go on, we must look at the evolution of process economic software. So before these advanced software tools came into play, engineers in the past relied on making calculations and cost estimations by hand. They also use nomographs and basic spreadsheets, which would be displayed in the next slide. They use these to perform their economic analysis. Due to the complex nature of performing these calculations by hand, there was a high level of uncertainty in decision making. Advancements in computing introduced mainframe tools, and these mainframe tools came with early stages of process economic software, which made parametric costing something possible. However, these software tools lack dynamic simulation models due to underdeveloped software in the past. In recent years, the maturation stage of process economic software programs have brought integrated tools that support capital expenditure, operating expenditure, which is OPEX and CAPEX, cash flow analysis, such as net profit value and internal rate of return, and sensitivity studies. All these are features of modern process economic software, which make them very powerful tools and indispensable to chemical engineers. This slide displays images of a simple nomograph. So to the top left is a diagram of a simple nomograph. Below that is a diagram of an early spreadsheet, which had to be manipulated by hand. And to the top right of both of them is a Monte Carlo distribution diagram, which is used to perform sensitivity and risk analysis. So this slide gives an overview of the uses of process economic software. So as mentioned before, they are used for capital cost estimation, operating cost estimation, that's the OPEX and CAPEX. They are used for process optimization. They are also used for economic analysis and profitability, sensitivity and risk analysis, and reporting and visualization. The applications of process economic software in chemical engineering is the highlight of this presentation. Process economic software programs are used throughout the plant's life cycle, that is, from the initial plant design to the actual operation of the plants, and thus the steps below have been modeled to follow through from the feasibility studies and early design through to the supply chain and market integration. Beginning with the feasibility studies and early design, process economic software are able to screen the different configurations for producing a particular product. So for instance, starting materials, catalysts, and many other factors. And then they're able to give the corresponding rate of return of all these different configurations. This ability leads through to the second stage, that is the detailed design and equipment selection. So based on the different configurations, from the feasibility study stage, process economic software can then calculate the total analyzed cost for the respective configurations and determine the most efficient equipment sizes and operating conditions. This then follows through to the cost tracking through the project phases, as the initial projections for costs are estimates and then they are bound to change because of market volatility. So that's feedstock prices, catalyst prices may change, and thus process economic software are able to model these changes in prices and reflect them in the overall projection. Again, the next step, process economic software are able to model operating cost analysis and production economics. So from OPEX, that's the operating expenditure, process economic software can directly model all expenses, that is all costs, cost of maintenance, feedstock, livestock, cost of maintenance, feedstock, catalysts, and many other costs, as well as all the income. So the income from sales and basically the cash flow of the plants. So they are very powerful tools and they're able to model such expenses. It moves through to the technology evaluation and process improvements. So if the design of the plant, let's say a part wants to be improved, a more technologically favorable portion of the plant wants to be replaced, that change can be modeled within the process economic software. And by being able to do that, you're able to directly see the projected increase or decrease in your profit margins. So if it's economically favorable, then the decisions are based on that. Again, process economic software tools can perform sustainability and green engineering metrics. So they're able to estimate the environmental impact, that's in terms of the cost, and then the cost of pollution as well, as a result of the operations of the plant. And then finally, they are used in supply chain. They can model supply chain and market integration. So this is basically the entire framework of the whole plant, and from gathering data from operations, sales, and everything, and then they can make detailed reports and projections on all these things, all these factors. And yeah, so this is an overview of the applications in chemical engineering. Process economic software tools have a high level of integration with other engineering tools such as process simulation software, dynamic modeling tools, enterprise systems, mechanical design tools, and most importantly, AI and data analytics platforms. Although process economic software tools are powerful, they come with their own limitations and challenges. Some of these are they're highly data dependent. Then modeling with these software tools is highly complex. They face transparency issues, and the cost of owning the licenses to this software is very high. So these are a few of the limitations of the software. In the near future, process economic software tools are projected to have a higher level of integration with AI, making autonomous systems possible. Again, it's projected that they may have cloud-based platforms, so to make working with this software remotely possible. It's also predicted again that they may have supply chain modeling. That is, future platforms may be able to cover wider parameters of costs along the supply chain line, and then finally enhance sustainability metrics. Though they are highly complex software programs, process economic software tools are very powerful tools for modern chemical engineers. With these tools bound to be even more powerful in the coming years, chemical engineers can utilize them to be even more productive, making the idea of a brighter and eco-friendly future a possibility. Thank you.